This is the last day of notes for chapter 22. It's going to cover other types of reactions and take us all the way through the end with polymers. So we're going to start out by talking about elimination reactions. And this chapter has lots of stuff. It's lots of things to remember. So what you have to do is try to find a way to help you remember. Elimination reactions, take a compound, and we eliminate two of the legs, fold them in to make a double bond, or if it's a double bond, we eliminate two of the legs and fold it in to make a triple bond. One that you're probably going to see on the test would be dehydrogenation, and remember, it's dehydrogenation. It has hydrogen in it. We're taking two hydrogens out. The two legs fold in, we get double bond or triple bond. And you can take it two steps to get an ethyne like you see there. Now notice on that page I have hydrogenation too. That's not elimination reaction. I wanted to show you that it has like a heads and tails, two different sides of the coin there. Hydrogenation is the opposite process. So we're adding two hydrogens, and both of those have the word hydrogen in them. So don't think of water, think of hydrogen. All right, so we move on, and dehydration reactions, hydra, think of water. So on a dehydration, we're removing H and OH from adjacent carbons, and that would also be a type of elimination, even though I've got it listed under addition reactions. Make sure that you kind of draw an arrow back to that on the previous page. So page 804, there's a summary of addition reactions. We're going to talk about all of those types. You can see here that it's basically like hydrogenation, except instead of H and H, we've got a general format here, X and Y. Whatever the two things are that we're adding, we basically take away a double or triple bond, fold two legs up. Both of those ingredients become, they call those legs home. So you can see how we've got now a single bonded compound with X and Y. Here's some addition reactions. Notice I've got them all starting with a double bond, and then we end up with a single bond, and both of the things we're adding are now they end up on the two legs, the two new legs. If it's a triple bond, same thing happens. Two legs fold up. Now we have a double bonded compound. H2, H2O, Br2, those are examples of addition reactions. Oxidation reduction. I want to remind you, write this down somewhere, that oxidation is the adding of oxygen or the removing of hydrogen. Reduction is the adding of hydrogen or the removal of oxygen. So make sure that you know those connections. So we oxidize a hydrocarbon, and the oxygen jumps in on an H and makes an OH group. We now have an alcohol. If we further oxidize, add oxygen with catalyst, the alcohol becomes an aldehyde or a ketone, depending on whether it's first or second degree alcohol. And then if we further add an oxygen to an aldehyde, we get a carboxylic acid. So look over that list. Those are some tougher equations. Might be, if I add one of those, be to separate the 95s from the 100s. So do look over those so you can see what's going on each of them. So here we have hydrogenation again. Remember, I had hydrogenation on that first screen. It didn't really belong there, other than I was showing you that it was a two-way process. So here it is as an addition reaction, and we've got a catalyst of, I think palladium is our catalyst here, and the two H's add on to the two legs that fold up from the double bond. That went away. Polymers. So there are two main types of polymers, and the way to remember those are that an addition polymer, like when you add 2 plus 2, the whole thing is in the total. So on an addition polymer, everything you put together comes out to be a total. On the condensation polymers that we've seen already, we pull something out so that the two compounds can crash together and become one. Remember, a good example of condensation reaction would be two amino acids. I am going to ask you to know, I'll say draw the general structure of amino acid, label the functional groups. So you should be able to do that with the amino group and the carboxylic acid group. Should also be able to show me a condensation reaction where they add together. So going to finish up the last section talking about polymers. and properties of those. Two main types of plastic polymers. One's a thermoplastic polymer, and that can be remelted, formed into new products over and over. That obviously is the best choice. We also have thermosetting polymers, and the thermosetting polymers are the ones that we really can't use again, because when you melt them, they don't melt into new things because they're all one molecule. It just kind of degrades or destroys the molecule. It ends up being kind of a burnt plastic mess. You can chop them into pieces and recycle them for some uses like packing material, and should know the difference in those two types of polymers. Currently, only 5% of plastics are recycled. That just is not a good number. So you know, we obviously need to try to increase on that. What doesn't get recycled goes into landfills and lasts for a long time. You know, degrading that is hundreds of years. In the ocean, it dissolves, and all the bad chemicals from the plastic end up going into the ocean water, or fish eat them or get tangled in them, and it ends up harming them. So that number, everybody here should go home and say, all right, we're going to try to make our recycling bin as big as our trash. And we finish up. This is a list of types of plastics and the recycling symbols for those. Look over them. You should understand what the numbers represent and what the symbol represents. Those are the different types of plastics. That finishes the chapter. You should look over all your notes, look through the practice pages, work as many of those as you can, work hard, and good luck on the quiz and test.